Hello, good morning everyone. Today I would like to share with you a new chapter that is the Fourier Transform. So in this lecture, you will study about the Fourier series, how to change from the Fourier series to Fourier Transform, amplitude spectrum of the Fourier Transform, the Fourier Transform pair using the table, and the inverse Fourier Transform. So let's overview. Okay, what is the Fourier series and Fourier transform? Actually, the Fourier series is for the periodic signal only, while the Fourier transform is for non-periodic signal. And Fourier series is for time domain, is in time domain representation, whereas Fourier transform is in frequency domain representation. So chapter 3, we study the Fourier series expansion to approximate the signal that are periodic in time. So in this chapter, we use the Fourier transform to express the non-periodic signal. So what is Fourier transform? So Fourier transform is a method for representing signal and system respond in frequency domain. So it is in frequency domain as I told you just now. So Fourier transform allows us to extend the concept of a frequency spectrum to non-periodic function. So these are physical reliable signals has a Fourier transform such as the unit step, the exponential. All those has a all those are the Fourier transform. So now let's investigate what is the relationship between the Fourier series and Fourier transform and how is transformed from the Fourier series to Fourier transform. Okay, do you still remember this formula? This is the Fourier series exponential, right? Okay, this is the formula that you study in the Fourier series. Okay, xn is the summation, xt is the summation of the xn and the exponential. Okay, this Sn is referred to the 1 over T naught, and then integration xt exponent minus j 2 pi nt over T naught. Okay? Where 2 pi over T naught is referred to the fundamental frequency. Okay, 2 pi here, the 2 pi over T naught is referred to the fundamental frequency. And the spacing between the adjacent harmonics is referred to the delta omega, which is n plus 1 omega naught minus n omega naught, that is equivalent to omega naught, which is, as you know, is 2 pi over T naught. So let's say the extension of the Fourier series to a aperiodic signal. What is meant by aperiodic signal? That is non-periodic. Okay. The extension of a Fourier series to a periodic signal can be motivated by generating a periodic signal from a periodic signal. So you transfer from the aperiodic to a periodic signal by extending. How to do it? By extending the period to infinity. You extend to infinity, so you get a non-periodic signal. So if we let the T naught it goes to infinity, then the limits of periodic signal will be reduced to the aperiodic signal. So this is the example to change the aperiodic signal to change the periodic signal to aperiodic signal. So this is the periodic signal in which the signal repeat at T naught. Okay, and then you change to the aperiodic signal. So how do you change the from periodic signal to aperiodic signal? Yes, you increase the T naught. So means that you increase the T naught. If there is no T naught, means that it is not a periodic signal because the signal never repeated. This is the formula for the Fourier transform. Okay, this is in the frequency domain, which is omega. Okay, x omega is referred to the. This is the symbol for the Fourier transform. So Fourier transform of the xt. Okay, equivalent to the integration xt exponent j omega t dt. So this is the formula that you need to know. Let's say if the question asks you to do by definition, so definitely you need to use this formula to solve the question. This graph is show the amplitude spectrum for a xn for t naught equal to 5 seconds. And then this is for t naught equal to 10 seconds. Okay, you can observe that the spacing between the adjacent harmonic is getting closer. Okay, this is also the same. This means that the frequency component are getting closer as the period T0 is increased. Okay, this is for T0 equal to 50 seconds. Okay, and this is for the 100 seconds for the T0. What is the meaning? What is the meaning by increasing the T0 value? What's the meaning? Okay, as you know too, as the period T0 increase, the amplitude spectrum getting smaller. So initially it's from 0.2 for T0 equal to 5 seconds to 10 power of minus 3 when T0 equal to 100 seconds. So the spacing between the adjacent harmonic or the frequency spectrum are getting closer to each other. So means that if T0 goes to infinity, the coefficient will also become continuous value. Okay, so there is something about the Fourier transform, the introduction. So now let's go for the Fourier transform example. Find the Fourier transform of the following function using the definition of ft. Okay, class, do you still remember just now I told you that by using definition. So by using definition, it means that you have to use the formula. Okay, so let's do this one. Delta t. Fourier transform of delta t, what do you get? Okay, as I told you just now, this is the formula. X omega equal to the integration from negative infinity to infinity xt exponent j omega t dt. So your xt refer to the question is the delta t. So you substitute the xt with the delta t. What is refer to the delta t? Delta t is mean what? Delta t means that is 1 at t equal to 0. So you only have 1, other will be 0. So you only have exponent minus j omega t when t equal to 0. Others, you don't have the value. So you substitute t equal to 0, you get 1 only. Okay, so xt, when you draw xt, is delta t. Delta t is 1 only. But when you draw the x omega, which is in the frequency domain, so x omega is frequency domain, which means that is a Fourier transform already. This one xt is the time domain, still is a continuous, okay, in the time domain. So x omega is equal to 1. So you draw a line of 1. Okay, class. Let's say if you have a signal xt equal to rectangular t. So first of all, you need to know what is rectangular t. It's a rectangular signal. Okay, rectangular t means that it's from negative half to half. Okay, amplitude 1. So the limit is from negative half to half. Okay, so this is the limits for the integration. And the xt here x rect t means that it's 1. If 2 rect t means that it's 2. So xt is 1. Okay, this is the formula. You just copy down the exponent negative j omega t dt. Okay, and then you perform the integration. Okay, you perform the integration, you get 1 over negative j omega. And then you put the limits from minus half to half, and then substitute the value t to half and minus half. So this is, you get this. And now, okay, if you look at here, okay, if you look at here, you have exponent, and also you have the j. So if you have j, you still remember the exponent j theta, the Euler formula. So exponent j theta equal to j theta plus minus, okay, j theta plus, you still remember that one is a cos or sine? If the sine is what? Exponent j theta minus exponent minus j theta over 2, right? 2j, right? So that is the sine. So if you look at here, you have also j. So it's definitely, if divided by j, it's definitely it's a sine. It's a sine. So if a sine, you must fulfill the form of the sine. So means that it's a exponent j theta. So theta means exponent j omega over 2 minus exponent minus j omega over 2 divided by 2. So when you divide by 2, you need this form, right? Divide by 2. So it means that you need to multiply with 2 so that you can cancel out. Okay? So this part you can change to the sign. So you have 2 over j omega sine, 2 over omega sine omega over 2. Okay, so if you change again, you get sin omega over 2 over omega over 2. You get sin omega over 2. And now you look at if the xt is equal to cos omega naught t. Okay, so you change the xt equal to cos omega naught t. Okay, you change the form. This is the cos. You change to the exponent. So exponent j omega naught t plus exponent minus j omega naught t divided by 2. Okay, so this is the cos. So you take out the 2, you have 1 over 2. And then you time with the exponent minus j omega t. So you multiply in, you get j omega naught t multiply with exponent minus j omega t. Okay, so you multiply in, you get this one. Minus j omega minus omega naught t. Okay, plus with the second part. So this one multiply with this one. And then you combine together is minus j. You write down the omega first. So omega minus, so minus and minus, you get plus. So plus omega naught t dt. So the integration of the exponent, you get exponent negative j omega minus omega naught t. You will get 2 pi delta omega minus omega naught. Okay. So you get this one, you cancel out the 2, you get pi delta omega minus omega naught plus pi delta omega plus omega naught. And then this is you plot the time domain and the frequency domain. So time domain is a cos. Frequency domain you have only delta. Okay, with delta equal to minus omega naught and the omega naught only.